Okay, everybody, this is a guided walkthrough for the local target challenge over at picoCTF as part of their Pico Gym exclusive set of challenges. The description says, smash the stack. Additional details will be available after launching your challenge instance. So this is a challenge where you need to start up a virtual machine to begin the challenge. So you can just click on the blue button over here labeled launch instance, and that's going to start up the virtual machine that you need to contact to finish the challenge. So it says, can you overflow the buffer and modify the other local variable? The program is available here, and there's a link. You can view the source here, there's another link, and you can contact it, you can connect with it using this command over here. So we're not going to be using the command to connect with the server quite yet. We need to inspect the binary, and we need to inspect the source code for the binary. So we're going to right click on the links, and we're going to download those files. We're going to go to our web shell. We're going to type in wget, paste in the address that we copied, and that's going to download the binary file. So the other file we need to get is the source code file. So highlight the other one, copy the link, then go over to your web shell, wget space, paste in the address, hit enter. And after you're done, you should have two files in here. So local target and local target.c. Before we start the challenge, we should make this binary executable so that we can actually run the file. So just run chmod +x local target. Okay, and then afterwards, we can tell that the binary is executable because it turns green in the terminal here. Okay, so the next thing we need to do is we need to take a look at what's going on with the binary inside of the source code. So the reason why these binary hacking challenges give you the source code is so that you don't need to reverse engineer the challenge. You don't need to reverse engineer the binary, rather. You can just take a look at the C source code and then try to identify where the binary, or where in the source code the code is vulnerable. So we're just going to use nano to take a look at this stuff. Whoops, that is not what we want. That's what it looks like when you open up a regular binary using a text editor. You don't want to do that. Okay, so nano local target.c. Okay, so we need to identify where the binary is vulnerable based on the source code here. So we see here that there's a buffer defined in here. So input is one of the buffers. It's set to 16 bytes. So in these type of binary hacking challenges, if it's a memory attack that we need to do, we need to understand how large these buffers are so that we can send an appropriate number of bytes to overflow the buffer in case that's the method of attack. Okay, we see another variable that's defined over here, which is equal to num, and it's equal to the number 64. So it prints out enter a string, and then it uses gets to record our user input. So gets is an unsafe function inside of C because gets doesn't check if the buffer that we're saving to is smaller than the input that the user puts in. So whatever we put into gets, or whatever the user puts into gets, is going to be saved to input. Input is only set to 16 bytes, which means that if we send over 16 bytes using the gets function, we're going to overflow that buffer and cause a problem. So we also need to figure out how to win in this case. So normally in these type of challenges, we need to access a file called flag.txt. So if num, this variable, is equal to 65, it's going to print out a message that says you win, and it's going to open up the flag.txt file and reveal its contents. So the thing is that there's no way in the regular program execution where num is going to equal to 65, because num is initialized to the number 64, and inside the program, there's no way for us to directly access the num variable and change it. So we need to find some sort of software vulnerability to turn the num variable into the integer 65. And well, let's talk about how we do this. Okay, so this is picoGym exclusive local target. This challenge is an example of a variable overwrite binary hacking challenge. So we want to overwrite this num variable here that is set to 64, and we want to make it 65. So in variable overwrite challenges, the goal is to overwrite a variable that the program uses, but is not modified during regular program execution. So we need to figure out how to change the variable value. In this binary, if the num variable is 65, then the contents of the flag.txt file are revealed. So what we can do in this particular exercise is we can do a buffer overflow attack via the gets function. So the program uses the cgets function to record user input to the input buffer, and the gets function is a memory unsafe function, which can be used for buffer overflow attacks. So part of doing binary hacking challenges is identifying where in the source code the binary is vulnerable. So buffer overflow causes data to overflow out of the memory buffer into other parts of the program memory. And in this case, it can be used to overwrite the num variable, which is our goal. So let's just imagine that the program memory is over at these different addresses. So the input buffer is over here, and if we put too much data into the input buffer, it overflows into other parts of the memory and causes a buffer overflow. So the buffer for input is 16 bytes, so we need to send at least 17 bytes to overflow the memory buffer and overwrite the num variable. So the last thing we need to understand before we start attacking the binary is how decimal numbers are stored inside of computer memory. So in program memory, decimal numbers are stored as bytes, which are represented by hexadecimal numbers. So if we want to put the number 65 into the num variable, we actually want to use the hex byte hex 41 or the ASCII character A. So these regular decimal numbers inside the memory, they're all represented using hexadecimal. So let's go ahead and solve the challenge. Let's go over to our web shell. Okay. So let's get out of here. If we run the local target binary, it's going to say enter a string. So if we just enter in any old string, it says num is 64 by, but we want num to be 65. So the way we do this is we use the buffer overflow, and remember that the buffer is 16 bytes large, so we need to send at least 17 bytes. So local target, we'll send a string equal to 16, so that's 10, that's 16, and then we'll send an extra byte here in the form of the A character. Okay, and it says num is 64. Num is 64. Hold on. How many bytes did we send? 1, 2, that's 10, 16, 17. So 17 wasn't enough to overwrite the num variable. But let's try that again. Okay, 17, 18, 19, 20. So we send 20 bytes here, and it still says num is 64. So what we need to do is we need to find out how many bytes we need to send to the binary before this num variable gets overwritten. So the way we can do it is we can do it like this. There's a program inside of the web shell called Radare2 or rag2, which we can use to create a pattern of characters. And then after we create the pattern of characters, we can look for that pattern inside of the buffer overflow. So we'll make I don't know, 200 characters. So what we do here is we create a pattern of 200 characters that we can feed to the binary. Okay. And we're just going to run this, and then we're going to paste in the pattern that we created. And it says num is this over here. So what we want to do is we want to convert this over to hexadecimal characters, because remember, inside of the memory there, it's, what is it called? It's represented using hex. So I'm just going to copy this. I'm going to convert this to hex. We could use a bunch of different tools. I'll just use like a web tool. Let's see, decimal to ASCII, decimal to hex. So decimal to hex converter. So we're going to enter our decimal number. We're going to get our hex. So it is these hex digits over here. Okay. So once we have this, we can use the same tool, which is the rag2 tool, rag2q, and then put in this number. So we'll make sure that this is being interpreted as this number right here. And it says little endian 24, big endian 1. So we need to send 24 characters to the binary before it enters the num variable here. We can confirm this by sending 25 characters. So that's 20. We'll send 25. Okay, and then number is 53. So why does it say 53 now? It's because this is so 5 is what should be in here. Okay, so 53, if we take 5, this character here, and then we convert it to hexadecimal. Actually, no. We go over to the ASCII lookup chart. So we do ASCII to decimal. Okay, so if we do ASCII to decimal, we'll put in the ASCII text 5, and we see in decimal it's 53, which is what we saw. So what we want to do is we want to make it the number 56. So that is 56, right? Let me check. Oh, we want 65. Okay, the other thing we need to do is we need to create a flag.txt file in here so that it can actually read the thing. Okay, so we're just going to quickly make a flag file. So echo out to flag.txt, HackerFrogs, like and subscribe. Okay, and so if we manage to see this message from flag.txt by doing the buffer overflow attack, then we know that we have the correct number of bytes. Okay, so what we can do is we can just run local target, and as far as the ASCII string that we want to send is concerned, it's actually the ASCII text for the letter A. So the letter A is decimal 65, which is what we're putting in the memory. So if we send the capital A as our payload after our offset of 24 characters, then we'll get the answer. Okay, so this is what we do. Sorry, enter a string, right? That's 10, that's 20, that's 4, and then we send our A as the last character, which is going to be interpreted as 65. Okay, it says num is 65, you win. HackerFrogs, like and subscribe. So we reread the message inside the flag.txt file. So this is the string that we need to send to the online binary to finish the challenge. This is how we're going to do it. Okay, we need to restart the instance because we've already spent 15 minutes. Okay, so just restart the binary, or sorry, restart the challenge. And then we've got our netcat command here. So we can just copy it and then go over to webshell and then paste in the command. So netcat, this thing. Okay, enter a string. So we're just going to use the same string we used before. And this is going to overflow the buffer, which is 16 characters long. And then there's a bunch of other input that we need to overwrite in order to get to the num variable here, which we put a into, and then we get the flag. Okay, your number is 65, you win, and then we get the flag here. So we just need to copy the flag, go over to the challenge page here, paste in the flag, submit the flag, and then we're finished. So everybody, that was a guided walkthrough for the local target challenge over at picoCTF as part of their Pico Gym exclusive set of challenges. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.